For question 1, we have a piecewise function that models the number of fish in a pond at time t years. So our first question is asking us to find the limit as t approaches infinity of n of t. So the first thing we need to figure out is which of the three parts of the piecewise function we're going to use. Hopefully you can see that infinity is a huge number. It's definitely going to be in the greater than 8 section. So we're going to use that for our limit. So hopefully you remember that when you're taking the limit at infinity of something where the highest term has the same degree, meaning that we have t to the first and t to the first, both in the numerator and the denominator, you just look at the coefficients. So my limit is going to be 80 divided by 0.05, which ends up being 1600. Remember that our units are fish. So if you got the 1600, that's the first point that you can get on this problem. Next thing you need to do is write the interpretation. So the interpretation, don't overthink it. You just mainly need to mention time. You need to mention fish. Interpretation is that as time increases, the number of fish in the pond approaches 1600. You can also say something along the lines of, after many years, the number of fish in the pond approaches 1600. So in order to get the second point for this part of the problem, you just need to explain the meaning in the context of the problem. So in order to prove that something is continuous, you need to check 3 things. So I wrote it out up here. You want the limit as t approaches 8 from the right to be equal to the limit as t approaches 8 from the left. And you want that to be equal to the function evaluated at 8. So you have to check all 3 of those things. So let's go ahead and do that. I'm actually going to start with the easiest one, n of 8. We are going to use the equation where we know t is equal to 8. So we're going to use the bottom one. You're going to substitute 8 in there. So then when I do that, I end up getting 350. Next thing I'm going to do, the second easiest one, is going to be the limit as t approaches 8 from the right-hand side. The reason that one actually is easy is because 8 from the right-hand side is going to be that bottom equation that I just did. I know that that's going to be 350. And actually, you probably should, just in case, write out all the work for that, just to show that you know exactly what you're doing for that one. Okay, so then the last thing is the limit, as this should be a t, by the way, t approaches 8 from the left. That is going to be that middle equation. So you get 25 times 8 plus 150. That also is going to give you 350. So actually, since all 3 of these are equal, then we know that the function is continuous. So please, if you have a question like this, make sure that you actually answer the question, something along the lines of, yes, n is continuous at t equals 8. There are a lot of people that do lots of work on these type of questions, but they actually forget to answer the question, even though they know the answer. Just assume that whoever's grading it doesn't necessarily know what you're thinking. So make sure it's very clear that you're answering the question. And there's a few ways that you can write the answer. I'm just going to say because the limit as t approaches 8 of n of t is equal to n of 8. We know that the limit is going to be, if these two are equal, then that is going to be equal to the limit as t approaches 8. This one should have a negative right there, by the way, in case you were wondering what that little dot meant. So for this problem, in order to get full credit, you need to, first of all, you need to answer the question and write a justification. That's 1 point. You need to check the limit from the right, and you need to check the limit from the left. So it's important that you check all of those and that you offer a justification as to why it is continuous. So for part C, I'm hoping that you realize by now that if you see a question that has this setup, is there a time t for this interval at which something happens, that's a sign that you're using one of those theorems. It usually is the intermediate value theorem. Sometimes you'll see the mean value theorem, occasionally the extreme value theorem, but it's often going to be the intermediate value theorem or maybe the mean value theorem. So they tell you that the function is continuous, which is good. We need that. Is there a time for which n of t equals 250? So first thing I'm going to do is I'm going to say n is continuous. Generally on these problems you will get a point for this one. This one actually they don't give you a point for that, but you should still make sure that you mention it because usually that's the first thing that the grader is going to actually be checking for. So we know it's continuous. The next thing that we're going to do is we're going to check our endpoints. So, and our endpoints are going to be at 0 and 6. So we know that when n is 0, we get 80, or when t is 0, we get n equals 80. When n is 6, you're going to use the second equation. And that gives you 300. So we have our endpoints. The last thing that we need to say is we need to mention the intermediate value theorem. So I'm going to say by the intermediate value theorem, if you say IVT, that's okay. Since we know that 250 is between n of 0 and n of 6, that means that n must hit 250 at some point between t equals 0 and t equals 6. And you'll actually notice I kind of just restated the question that I had up there. That's fine. If you do that, you don't have to be creative on it. Just make sure that you get all parts of this in here. You need to, in order to get full credit, you need to check and see what n of 0 and n of 6 are, which are our endpoints. You need to mention that the 250 or whatever value you're looking for is between those two things. You need to mention that you're using the intermediate value theorem, and you also need to check for continuity. So to get full credit on this one, you need to specifically mention the intermediate value theorem, or IVT, and then the other point is a little bit more vague. It's just for getting the right answer of yes with some sort of justification.